In your packet, you also have this handout here. There are 2 on each page, so you're going to cut across the dashed line there. And now that it's cut across the dashed line, you're going to fold it just like this. And cut along the dashed lines here. But you're only going to cut the front part. You're not going to cut this side at all. Okay, you're just cutting this front flap along the dashed lines. So just enough so that we can open it up like a window and see how to do these problems. And now they open up. We can see both how to do it, and then we'll have an example. So these 3 examples are going to be special cases when we're multiplying with binomials. You're going to see these 3 different situations a lot, and each of these is a particular pattern. And it's a really cool pattern because once you recognize it, it actually makes it a lot less work to do. You don't have to go through the whole FOIL method, because if you recognize the pattern, you get to skip right to the pattern. Now, that doesn't mean you can't use the FOIL method. I'm just showing you a shortcut if this helps you, okay? And if you recognize the shortcut now, it's going to make it much easier in the future when we start going backwards, because we're going to have to be doing this backwards as well. So let's start with this first one. The sum of a plus b squared. And when we do this generic example, a plus b squared, we're going to use a and b so you can see the pattern, but really you could have examples like x plus 3 squared, or w plus z squared. Okay? Those are all different examples of an a plus b squared. It could be a 2x plus 3y squared. Okay, those are all examples. But when I do the problem out, for you to see the pattern, I'm going to use a and b. So I'm going to open this up to something that's already written down because I wanted to use color, and it came out really neatly right here. So as an example, we have a plus b squared. I did a in purple and b in orange. So if I were to write this out, it would be a plus b times a plus b. And now I can use the FOIL method. So I do a times a gets me a squared, and the outside a times b gets me ab. Inside b times a also gives me ab, and then the outside is b times b, which gives me b squared. And so the pattern here is the middle 2 numbers are always the same. So it's a times b and a times b. So when I combine like terms, I've got 2 a times b. And we can use that pattern to skip the FOIL method altogether and go from here right to here. If we recognize that the first number is this one squared, the last number is this one squared, and in the middle we multiply a and b and we double it. So it's all about recognizing that pattern, and we'll see that in the example that we do. So now we're going to take this pattern that we found and we're going to use it on this problem. So instead of having to write out 3x plus 4 times 3x plus 4 and then do the FOIL method, I can break it down into this pattern here where it's the first term squared, so 3 times 3 is 9, x times x is x squared, and at the end it's the last term squared. 4 times 4 is positive 16. Now the middle is when I multiply these two together, right? A times b, and then I double it. So 3x times 4 would give me 12x, and when I double it, I get 24x. So that middle term when I combine them together, it becomes a positive 24x. So I skipped all that FOIL method and I went right down to the pattern. So 9x squared plus 24x plus 16. So that is the pattern for a plus b raised to the second power. The next special case is really similar to the first one, but now we have a minus b instead of a plus b. So let's take a look at how that affects the pattern. So if we open this up, we still have the square of a binomial. So if I write this out, I can still use the FOIL method. So it's a minus b squared. And if I write it out, that's a minus b times a minus b. And using FOIL, a times a gives me a squared. A times negative b gives me negative ab. And then the inside, negative b times a, is again negative ab. And then negative b times negative b is a positive b squared. And when I combine like terms, I have two of these negative ab's, so it becomes negative 2ab. So take a look at how similar these two are. The only difference in them is that here we are multiplying a and b and then doubling it, but we're adding that, right? So it's plus 2ab. And the bottom one, it's minus 2ab because this is a negative symbol. So that's the only difference in the two patterns, is that if you see an addition, that means you're adding in the middle. If you see subtraction, it means you're subtracting in the middle. But these values, a squared, b squared, 2ab, right, those numbers you get are going to be the same. So if we take a look at our pattern, I still have my first term squared, so that's 5 times 5 is 25. M times m is m squared. I'm squaring everything that's there. And at the end, it's my last term squared. So n times n, that gives me n squared. In the middle, I'm multiplying the two together and then doubling it. So 5m times n gives me 5mn, and when I double that, I get 10mn. And because this is subtraction, this is subtraction. So there's your pattern. Now, when you start doing these problems, you of course can go back to here, okay, to getting 3x plus 4 and then just writing out 3x plus 4 times 3x plus 4 and then using the FOIL method. So if it's easier for you to just write it all out, you can do it that way. But if you can recognize patterns, you can save yourself time. And really this whole unit's about saving ourselves time and recognizing patterns. The last one we're going to do is a plus b times a minus b. So for this one, it could be a problem like x plus 3 times x minus 3, where it's the same thing, but the only thing that's different about them is this is addition, this is subtraction, or it could be switched around. It could be like y minus 4 and y plus 4. Right? Same numbers, but this is addition here, and this is subtraction. Okay, so again, we have patterns, and we're going to open it up, and we're going to look at what that pattern is. And this one's actually really cool. So if I write this out, a plus b times a minus b, and I use the FOIL method, I'm doing my first. A times a gives me a squared. My outer, a times negative b, is negative ab. My inner, b times a, is positive AB. And then my last, b times negative b, which is negative b squared. And when I combine like terms, you'll notice that these two cancel each other out. Negative AB, positive AB are 0. So this one's actually really fast because your final answer is just your first term squared minus your second term squared. Okay, so for example, we've got x plus 3y times x minus 3y. So I've got my first term, which is x. So my first term is x squared. And I'm subtracting my second term squared, 3y. 3 times 3 is 9. Y times y is y squared. So this is just x squared minus 9y squared. Now, if we wanted to FOIL it out, we could do that, but those middle terms would cancel each other out, and you'd just be left with x squared minus 9y squared. So again, this is all about these three problems here that we've done: the a plus b squared, the a minus b squared, and then the last one, a plus b times a minus b. You have those skills from the flip chart we did in the previous video to actually use the FOIL method and do these out. But this part was just for helping you save time and recognize patterns. And it's certainly going to help you when we start going backwards, when we start going from this here and putting it into something like that. Okay, so eventually we're going to go from here to here, or from here to there. Okay, so that's not yet. That's called factoring. No, we're not there yet. So there is another method to multiplying with polynomials. It's called the box method. I'm not going to show it to you here because you have the necessary skills to meet expectations on the competencies and do the practice work. But if you notice the relearning section, there's going to be a video that's called the box method for multiplying polynomials. So that's a different method if this one confuses you, or if you'd like to see it a different way, please use that one. It's a little more straightforward. It's a little easier to see, but this way helps you recognize patterns better. And that's why I do it this way first. So now that we're done with the videos, you can tape them into your interest. Just like so. You can put these on the left side and these on the right side to save some space. And then you're going to do the practice problems from the textbook.